We are on practice quiz number 2, the sigma notation part. Number 1, you are to evaluate the sum, which means write out the terms and add them. So the first term would be when n is equal to 0. So n equals 0, and then you put negative 2 to the 0, 0 minus 1. Plus, when n equals 1, you'd have negative 2 to the first, 1 minus 1. When n equals 2, you would have negative 2 squared times 2 minus 1. And this is where a lot of people go wrong. That 3 doesn't mean stop when you get to 3 terms. That means stop when you get to n equals 3. So n equals 3 would actually give us a fourth term here, negative 2 to the third, 3 minus 1. And then evaluating this would be 1 times negative 1 plus negative 2 times 0 plus positive 4 times 1 plus negative 8 times 2. So negative 1 plus 0 plus 4 plus negative 16. Negative 16 plus 4 is negative 12, negative 13. The next sequence asks us to write summation notation for the sequence. Well, we can see that this is starting with maybe term number 1. Actually, we don't know what term I don't know what I want to start with right now. That's a sigma. It's going to be an infinity sign at the top, though, because we know that it's an infinite number of terms. Now, one trick to writing a sigma notation is to number the terms and see how the term numbers are related to the terms. And you see here that the term is 3 times more than the term number. This is 3 times 1, 3 times 2, 3 times 3, 3 times 4. So when I wanted to find term n, this would be 3 times n. So I can just write my rule as 3n, where n equals 1 to infinity. So that's the answer. Now, what if you had noticed that this was arithmetic? You might have noticed this is arithmetic where you're adding plus 3 each time. And you might have said, oh, a sub 1 is equal to 3 and d is equal to 3. And I know the explicit rule for an arithmetic sequence is a sub n is equal to a sub 1, the first term, plus n minus 1 times d, times 3. And that would have also been a perfectly good rule. And in fact, if you simplify this, 3n minus 3, you end up with 3n. So it's exactly the same thing as you did just by looking at the pattern in the terms. This next sequence is neither arithmetic or geometric, but it has a really distinct pattern of fractions. We can see that there are 5 terms. I could number them 1, 2, 3, 4, and 5. And I would notice in my pattern here that the numerator is always 2 more than the term number, and the denominator is 3 more than the term number. So if this were n, this would be n plus 3, and this would be n plus 2. So my sigma notation can be written when n is equal 1 through 5. So I've numbered the terms 1 through 5 of n plus 2 over n plus 3. Now I want to show you there are more ways to write this. What if I started numbering, instead of starting numbering at 1, what if I said, let's start at 3 and number them 3, 4, 5, 6, and 7. So the numerator is just the term number. So I could also have written it like this. N equals 3 to 7 of n over n plus 1. So either of these are correct, and you could start at any other number you wanted to, just as long as when you plug in the numbers from 1 to 5 here or from 3 to 7 here, you get those 5 terms.